Alrighty, today we're going to be doing exercises 1 and 2 from section 1.3 of Stewart's Calculus, Early Transcendentals, 7th edition, yes, and they're not too hard, too difficult. They have to do with function transformations and stuff like that, identifying the types of transformations and whatnot. So we're going to jump right in. I have the question here. This is actually copy and pasted from the book that I have on my computer. So this is from the PDF version, and this should be exactly what you have if you have the physical book. So one says, suppose the graph of f is given. Write equations for the graphs that are obtained from the graph of f as follows. So we have A will be our first one. A shift of 3 units upwards. Well, that's easy. That's just the function plus 3, right? B says shift 3 units downwards. Well, that would be the opposite, minus 3. A shift of 3 units to the right. Okay, so we're to the right is in the positive direction, so we're subtracting. So it's x minus 3 units. And D, I am assuming, yep, 3 units to the left. It's the negative direction. All right, a reflection about the x-axis. Now remember, we're going to multiply, but you have to remember you're either going to multiply the entire function or you're going to multiply just the argument of the function. And the argument is x in the parentheses for f of x. And to multiply, to reflect about the x-axis, we're going to multiply the entire function by -1. So that's e. Okay, so e is negative f of x. A, B, C, D, E, F. F is reflection about the y-axis. That would be the multiplying the argument by -1. G, a vertical stretch by a factor of 3. To do a vertical stretch, you have to multiply the function by that factor, the whole function. So we're going to do by a factor of 3. So 3 times f of x. E, F, G, H. And the last one, a shrinkage, a vertical shrinkage by a factor of 3. And a vertical shrinkage would be the division of the function by that factor. And you could also think of it as, this is the factor, 1 over the factor times f of x. It's the same thing, division and multiplication by a fraction. Same thing. All right, so question 2. Explain how each graph is obtained from the graph of y is equal to f of x. What is wrong with my thing? All right, so A. Okay, well, I'll do this in a different color. I'll do A. Y is equal to f of x plus 8. Explain how each graph is... Okay, so I would just say that this graph is a vertical, or I'll just say a translation upwards by 8 units. Multiplying the entire function by a number, a factor of 8. We're multiplying it, or not multiplying, we're adding. That shifts it up. And then B, y is equal to f of x plus 8. And that would be a translation to its left in the negative direction by 8 units. Okay, C. Y is equal to 8 times f of x. Well, that is a vertical stretch by a factor of 8. By a factor of 8. And then f times, or f of 8x. F of 8x would be a shrinkage, a horizontal shrinkage. So when you multiply inside the, or when you multiply a number by the argument, it's a horizontal shrinkage. So horizontal shrinkage by a factor of 8. Okay, E is negative f of x minus 1. Okay, so when we multiply the entire function by negative 1, it's a reflection about the x-axis. So that would be reflection. Sorry, I'll try to refrain from using cursive. About the x-axis, and there was something else. A translation downward by 1 unit. A translation downward by 1 unit, whatever. Okay, F is our last one. Okay, so y is equal to 8f of 1/8 x. Okay. Phew. Okay, so that when you multiply the entire function by a constant, you're doing a vertical stretch. So vertical stretchage of, well, by a factor of, what was it, 8? 8. And what else? It was, we're multiplying the argument by a fraction, 1 over 8. And we could also think of it as multiplying the argument by, or no, I'm sorry, we could also think of it as dividing the argument by that factor. And that would cause a horizontal stretchage by that factor. So this is and a horizontal stretch by a factor of 8. Alright, so that's exercises 1 and 2, not very